Right, class, this is a presentation about graphing. So you will be asked to graph once we're back in school. Not being in school, probably going to be reading and interpreting graphs more than doing graphs. But all graphs in science class must have these three things, which we will test over. So you must know that all graphs have a title, all graphs have labels that include units, and all graphs have a scale. So in the green is our title. Our title goes above on top of the graph, not below the graph, but on top, exactly where you can see. A lot of times, the easiest way to title your graph is to write what's on your what's your dependent variable, amount of CO2, versus your independent variable. So that's an easy way to make a title. But you could also title it based on what the experiment is. And for example, I happen to know this is about yeast respiration. So I could also title this yeast respiration rate. So that would be another title I could use. The other thing that has to have is labels and units. So label and then parentheses, the unit, label, parentheses, unit. And scale. So the scale is the numbers on the X and Y axis. That scale has to be the same on the X axis and then the same on the Y axis. I'm sorry, this is the X, this is the Y. So it has to be the same. So I want you to look at our scale. Did we start at 0? No, that's okay. If I look at my table here, the table amount of carbon dioxide is 9 to 21. So I have to just think, well, how many boxes do I have? How should I count? So it turns out I have enough boxes that I can count by ones. But do I have to start at 0 if I'm counting by ones? No, because on here the table starts at 9. So I started at 5. So my first box is 5, and then 1, 6, 7, 8, 9, 10, right 10. 11, 12, 13, 14, 15. So I am setting it up by ones. I don't have to write all of the numbers. I can write however I want, how to make it clear what it is. So then on the x-axis down here, that's the horizontal axis. And if I look, time here goes from 36 to 117. So can I count by ones? Well, that would mean I need 117 boxes, so, or a little bit less because it could subtract 36. But that's not realistic. So what should I count by? I could do 2s, I could do 3s, 4s, 5, 6, 7. It just depends on what works. In this case, I counted by 3s. Notice it starts at time 36. It looks like I do not start at 0, but I also didn't start that close to 36. But I'm counting by 3s, starting at the 24. If you count by 3s, then the next line is 27. The next line is 30. The next line is 33. The next line is 36. The next line is 39, and then you get to 42. So your scale has to be the same on the x-axis, and then it has to be the same on the y. The two do not have to be the same, and you do not have to have 0, 0 in the corner. So most graphs in science class are dots, line graphs, and we don't connect the dots, but instead we draw a best fit line. A best fit line is the average of over all the points. So the average, and the average is going to be somewhere in between your points, so you have about the same number of points above and below. You're always going to use your ruler to draw a straight line, and you have it half and half, somewhere in between all your points. You want to be as close to all your points as possible so you kind of can adjust your ruler. Now, remember, your best fit line does not have to go to the corner. There is no 0, 0 here, so there's no reason to have to draw through to 0, 0. That's not required. So that's the origin, right? And it doesn't have to touch any of the points, although if I had another point and it was right here, that's okay. We could go ahead and draw right through it. There is no one correct best fit line, but it does have to kind of follow these rules. So this too is a pretty accurate best fit line. So both of these would be good best fit lines that show points above and below on the line. Now, a best fit line is not this one though, right? So this yellow one is not a best fit line. This does not go in between all the points. It's just a random line drawn. The next thing that's really important for us is that we always use at least 70% of our graph that's provided to us in class. So I could have made this scale different. And if I had done so, then my graph is just in this little corner, and that's really not acceptable. So you have to make sure that you're scaling in a way to use at least 70% of the graph paper that is provided to you in class. So please don't make tiny little graphs. All right, now why we draw a best fit line is it helps us interpolate data. So that just means finding an answer between our data points. We could probably try to guess from the table, but our best fit line is actually how we're going to interpret the data and the numbers. So you're going to use the best fit line on the test to answer questions like this. How much carbon dioxide was present at 54 seconds? First of all, you have to think about, where am I going to look? 54 seconds. Down here is seconds. So we're going to look at the bottom, and then we're going to go up to the line. So we're going to find 54. There's 54 on our graph. We're going to go up to the best fit line. Then we're going to go across. And when we go across on this over here, we know that we're counting by ones. So 10, 11. So that must be about 10 and a half. So it's 10 and a half. 10 and a half what? Look at your units. Milliliters. In science, it's always a number with units we measure in science class. It's not just a plain number. Second thing we can do is extrapolate. So we can determine information outside of our data points. So again, if we draw a line past the last data point or below the first data point, then we can actually answer something outside of our data. So how long would it take to produce 25 milliliters of carbon dioxide? Well, we could guess. We didn't measure that, but we could guess. Again, the question here is in milliliters, so I'm looking on this side first, finding 25, going across to my best fit line, going down, and then counting it out, right? 117, 120, 123, 126, 129. So the answer is 129 seconds. I know I talk fast, so you just repeat these videos. That'll probably help you. I try to get through them as fast as possible, but then I feel like I am talking really fast. All right, so the other thing to show you is that when we graph, the dependent variable always goes on the y-axis. The y-axis is the one that goes up and down. That's the dependent variable. The dependent variable exists because of the independent variable. It is responding variable. It's the thing we're measuring in the science classroom. So the dependent variable on the y, the independent variable goes on the x, right? The x-axis goes across the line. So that's where we're going to find our independent variable. It's often defined as it will be present without the other variable, meaning time exists whether or not we're measuring something. So time is always the independent variable because time will always exist. So even up here, we decided when to record. So at time 36, we recorded the amount of carbon dioxide. At time 75, we recorded the amount of carbon dioxide. So we decided at what time we're going to record. That's the independent variable. The dependent variable is what we're measuring or is dependent on the time, right? It wouldn't exist without time. How much carbon dioxide is being produced is dependent on how much time there has been. All right, so just to practice a little bit before you do your work is what is wrong with this graph? So take a look. Press pause and look before I give you the answer. So press pause now. And then once you unpause, then the answer is what? What did this person do wrong? Well, what this person did was go up here, take these numbers off this chart, write the numbers down here, look here, take these numbers here, and put the numbers randomly on the chart. Can't do that, made no scale. So if you're actually looking at it, counting by different numbers, that is not a correct and true scale. That is wrong. Please don't make a graph like that. This is the way the graph is supposed to look if you actually make a proper scale and use 70% of your graph. So notice in this case, I counted by 2s on the y-axis, I counted by 1s on the x-axis, but here's interesting. Even though I counted by 1s, I skipped 4 boxes and made 4 boxes worth 1. I'm allowed to do that as long as it's always 4 boxes. So just keep that in mind as well. You can do a lot of different ways. Just there is a right way and a wrong way. Once in a while, you might have to make a bar graph. Usually bar graphs are left for when the independent variable is not a number, but is a word. So that's often why we have bar graphs, but you could use bar graphs for other reasons as well. You don't have a best fit line for bar graphs. You're just expected to read the bar graph itself. And then this is in our notes, and you can watch this video from Bozeman that also goes through graphs to extra help to make sure you understand graphing. All right, I sure hope you have a good rest of your day and you are able to complete your notes review.